I'm glad to be with you. I am here today to talk about our latest CO2 water heater, Q-Ton. I've divided my talk into 3 parts. The first part is the product outline. The second part is the actual operational performance and actual cost-saving results. Lastly, I'll show you various examples where Q-Ton is used. To begin with, I'd like to give a brief product outline. The Q-Ton water heater is a heat pump utilizing CO2 as a refrigerant, which is called EcoCute in Japan. Our product is for commercial use under the brand name Q-Ton. In Japan, especially home-use EcoCute has become very popular, reaching 3 million units in total shipment. We think this EcoCute using CO2 compressor is very innovative technology which was born and bred in Japan. The rated heating capacity is 30 kilowatts per hour. That means it has the ability to make 3 tons of 90 degrees Celsius hot water in 8 hours. The conventional EcoCute had some problems that are specific to the air source heat pump. That is, when operating under low ambient temperatures, heating capacity and heating efficiency decreased significantly. In other words, conventional EcoCute had difficulty in making sufficient hot water during winter. That was the major problem compared to the boiler system. Q-Ton was developed to solve the problem of heat capacity and heat efficiency dropping. Next, I'd like to show you the field test site and look at how Q-Ton worked actually, or whether as specified or not, and how the cost-saving results turned out. The site of the field test was a certain pharmaceutical company in Hachiman-tai, Iwate Prefecture, which is famous for heavy snow, as you can see in this picture. A kerosene boiler had been used for the hot water supply to the kitchen, the bathroom, and in part for space heating. Q-Ton was introduced for the purpose of the running cost reduction. The field test lasted for 1 year, starting from January 2011. Please look at this slide. This shows the actual operational status from January 25th to the next day. The horizontal axis is time. It was a very cold day when minimum temperature was about -14 degrees. A green line in this graph represents the actual heat capacity, and this red line stands for the actual hot water temperature. And well, the reason why Q-Ton sometimes stopped is partly because the storage tank was filled up, and partly because defrost operations were performed. So, looking at operating time, there are 2 major points to note here. One point is that the actual hot water outlet temperature was kept constant at 80 degrees Celsius as the set temperature, and the other point is that the actual heat capacities were approximately 30 kilowatts. That is just in accordance with specifications. Here, I'd like to talk a little about the other actual performances. In this slide, it shows the actual hot water temperature. The horizontal axis is ambient temperature. You'll see Q-Ton really makes hot water at 90 degrees Celsius under about -20 degrees Celsius ambient temperature. Next, I would like to deal with the cost-saving issue. Seeing this graph, almost every day, the lowest temperature was below -5 degrees. In addition, it snowed heavily on February 7th and 24th. This graph shows the running cost day by day of Q-Ton and conventional boiler system. The blue line is the Q-ton running cost, and the red line is that of the boiler. As you can see, Q-ton's running cost was lowered by almost half compared to the boiler. And regarding snowing, it is disadvantageous to Q-ton's operation. However, on heavy snow days, Q-ton's operational cost was much reduced, and at the same time, CO2 emissions were much reduced. Let's look at the long-term data. This data shows the actual monthly COP throughout the year. The COP peaked in July, and then it was 4.0. The COP is, as I said before, higher during summer. In fact, the actual monthly average COP was 3.5 to 4, whereas during winter, the COP was 2.2 to 2.5. Consequently, it ended up that the average COP throughout the year was 3.04. Next, I'd like to look at how much this COP being high contributed to cost-saving results. This graph shows the monthly running cost comparison between the boiler and Q-ton. The operational cost of the boiler is the gray bar. Q-ton's operational cost is the green bar. And the line graph is the accumulated running cost reduction amount. For example, in July, Q-ton's operational cost was about 18,000 yen, whereas the operational cost of the boiler was about 60,000 yen. In short, in July, Q-ton's cost was lowered to be about 1/3 as much as the boiler system. Throughout the year, Q-ton achieved 61% reduction in running cost and also 29% reduction in CO2 emission compared to a boiler. And what I want to stress here is that in Asia, for the most part, the average temperature is as a matter of course higher than this area. So it follows the running cost there will be lowered much more than this. For example, the average temperature is 20 degrees Celsius throughout the year. When calculated simply proportionally under the same calculation conditions at this site, the operational cost will be lowered by 70% and be 30% as much as the boiler system. We conducted winter field tests in 3 sites, that is, Hokkaido, Toyama, and already mentioned Iwate. The meteorological condition in winter is very severe in each place. The running cost of every site dropped by as much as 50% during the winter. And also, please note that heating efficiency in winter is the lowest of the year, so it follows the annual running cost will be lowered still more. Therefore, we can say Q-ton certainly has a very good effect on a running cost side and an environmental side. Many CO2 water heaters used to be well adopted in welfare nursing facilities or hospitals. Recently, CO2 water heaters have come to be widely used in the various fields. At last, I would like to introduce various cases. First, this is a hybrid system combined with a boiler system. This can reduce initial cost by utilizing the existing boiler and tank. This system takes advantage of each good side of Q-ton and the boiler. That is, the CO2 water heater is used for hot water supply, and the boiler is used for circulation heating, for example, space heating. Especially in a hotel or hot spring inn, this system has become popular. I would like to introduce an all-electric facility example. This facility is the largest all-electric school lunch center in Japan. In this facility, 6,000 meals are produced here every day. 12 Q-tons have a major role in supplying the dishwashers here with hot water. In addition, this is a warm bath facility in Hokkaido. 12 Q-tons preheat the feed water to the boiler. Finally, Q-ton is increasingly popular in the industrial sector. In food factories, much hot water is used for the cleaning or production process. To meet such heat demand, Q-ton is well suited, or for preheating feed water to the boiler. So, I've shown various cases where Q-ton is used. I've attempted to explain here that Q-ton has solved the problem typical of the conventional CO2 water heater and enabled the rated heat capacity to be sustainable to as low as -7 degrees Celsius, and that in the field test site, Q-ton lowered the running cost almost by half compared to the boiler and worked as specified without any problem, even under severe climate conditions. And lastly, that Q-ton came to be used in various fields. We think commercial use CO2 water heaters have sizable potential for future market expansion and would contribute to CO2 reduction consequently. And we hope that you will find the Q-ton CO2 water heater helpful for your business. That's all I have to say about this subject today. Thank you very much for your attention.